Welcome to my channel on pyspark tutorials. This video is all about handling missing data in pyspark. As you can see in the screen, uh, it's about handling missing data in pyspark. In the real world, it's very common that we will be working with incomplete datasets, which means you will have missing data. You have two basic options for filling in missing data. One is drop the missing data points, including the possibility the entire row. Second is fill them with some other value like average. The common practice is that we fill them in with some other value like average. There are also two different types of missing data to be aware of. Null values represents no value or nothing. It's not even an empty string or zero. It is simply null. It can also be represented that nothing useful exists. Second is NaN stand for not a number. It usually results of a mathematical operation that does not make sense. Example 0.0 slash 0.0. Let's start. Uh, as usual, let's establish a Spark session. Import find_spark_init, import pyspark from pyspark.sql, import Spark session. All these scripts are already existing in my cells. I will try to explain about the handling missing data scripts or codes so that you can also practice along with the dataset. Spark session.builder.appname nulls get or create will create a Spark session. Spark.jsc.sc.getMemory status.keyset.size will give us the number of cores. I will share the link to the dataset in the descriptions. Spark.read.csv. We are dealing with a Zomato.csv. Infer schema equal to true, which will automatically create a data um, type schema for the dataset. Header equal to true. Let's run this. It will hardly take half a minute. Now we can view the print schema using Zomato.print schema. Also, it, the point here to identify the columns with their data types. If we find any columns which should be integer type but it is string, or it is string type but it is integer, we can cast the data type and reassign the data type to the existing column. As we can see, approx cost for two people column, it should be integer type but it was string. Similarly for votes, it should be integer type but it was string. We are casting the integer type. We can now to pandas to view the data frame. As we can see, many non-nan values are present in this data frame, which will create ambiguities while working with the data frame for analytical purposes or query purposes. Note that nulls values appear as none in the pandas printout above. If we show the null values for the cuisines variable in attempt to view that first restaurant jalsa, we see it appear as null below. We can view the top 5 rows of cuisines having null values. The main point of this video is to handling missing data. This cell is creating a method which will take all the column names of the data frame, count the number of null values for each column, and percentage of null values for each column. Name column has 85 null value counts with 11% of null value percent, and online order having 8,111 with 11, sorry, name has 0.11%, online order have 11%. Listed in city, approx cost, disliked having max percentage of 65%. Another way to view this null value count and percentage is to find out the nulls percent and taking union into result set. Similarly, name has 85, 0.1%, online order have 11%, disliked having 65.3%. Now drop the missing data. PySpark has a really handy .ini function for working with missing data. The drop command has the following parameters: df.na.drop, how equal to any, threshold equal to none, subset equal to none. If we can find how many rows that affected before you actually execute it, it has almost dropped 63,000 rows, and we have lost almost 88% of data, which is not feasible and does not make any sense. For that purpose, we can use the threshold, which which can drop rows that have at least 8 non-null values. Now it has reduced to 2%, and only 1,694 rows are dropped. Is way better than the above method. Only drop the rows whose values in the sales column are null. Another way to do the above: drop a row only if all its values are null. So 0 rows are dropped. Now the main point is fill the missing values. We can fill the missing values with missing string in replacing the any in the data frame. So all the null values are filled with missing, but not the any because it is not a number. For this, we need to write another logic. Another way is to fill any with a number, any number. To replace the any with number. Also, we can specify what columns you want to fill with the subset parameter. For example, name is null, but na fill no name. In the name, it is no name. Now, the most common practice is to fill values with the mean value of the column because dropping will result into loss of data. In some cases where the missing values are large in numbers, dropping the missing values will result into loss of data. We have created a method fill with mean with df. This statement has created a aggregate function and for finding out the mean for each column. And finally, it is replacing the na with the mean of each column. And we have applied this for the votes column. In votes, it is replaced with the mean in place of null. Also, we can apply machine learning algorithms to handle missing data. This is an example of filling missing values conditionally, where A is where we have a list of informations, created a data frame with fruit and quantity, where A is the quantity. If the quantity is null, B will be 999. If quantity is less than 5, B will be 0. If quantity will be greater than 5, B will be 1. Otherwise, it will be -2. That is all in this video. We have covered how to handle missing data in PySpark. In summary, we have learned dropping the missing data points, including the possibility the entire row, fill them with some other value like average. I hope this video was helpful and happy learning.